Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a discussion on activity 2D2 to get you guys ready for that activity here. So, we're going to take some of the results that we learned in activity 2D1, so you might want to have that handy, all right, and kind of amplify on that and go further on that, and also connect our results that we learned from activity 2D1 with perhaps some prior knowledge that you learned in Algebra 2. Because in Algebra 2, I think you guys learned something called geometric sequences and series, and I'm going to connect the two. So let's pull in what we know about 1/9 from the previous activity. So if you want to get that out, okay, so you want to refer, let me just make note of this, you want to refer to activity 2D1, okay? So just keep that in mind. All right. So let's read the problem here. So using a decimal equivalent for 1/9, okay, so we're going to be working with 1/9 initially here that we found in activity 2D1. How can we determine the decimal equivalents for 2/9, 3/9, 4/9, 5/9, 6/9, all the way up to 8/9? You know, how do we do that? And then what do you notice about the fractions 3/9 and 6/9? We'll talk about that when we get there. And how is all this connected to what we know about 1/3 and 2/3? Okay, so let's start with what we know. So we know from the previous lesson. Okay, I like saying we know. Okay, that 1/9. Okay, is equal to 0.1 repeating. Okay, let's make sure that you guys know what that means. That's 0.1111111. Okay, forever. Okay, this is an infinite repeating decimal. So this, this bar right here over the 1 indicates that it repeats infinitely. So that indicates that it repeats infinitely. All right, there is no end. You can even verify that with a calculator if you want. We did that before. Okay, and so the question is, how do you use that to figure out all the other fractions from 1/9 to 8/9? So let's do that. So 2/9 is equal to 2 times 1/9, right? 2 times 1/9 is usually 2/9, because 2 times 1 is 2. Okay, so 2 times 1/9 is 2/9, but guess what? We know what 1/9 is, right? So this is 2 times 0.1 repeating, all right, which is obviously, well, it may not be obvious, but it should be obvious as 0.2 repeating. And again, you can verify this all with a calculator, okay? So if you just multiply 0.1 repeating by 2, you multiply all those infinite number of 1s by 2, you get 0.2 repeating. Okay, let's continue. 3/9, which is the same as 1/3. Okay, that's why they asked you about, you know, the connection between 3/9 and 1/3 and 6/9 and 2/3, because you can reduce that there, guys. Okay, it's the same thing as 3 times 1/9. So since you know what 1/9 is, you can take 3 times 1/9, which is 0.1 repeating, and multiply it by 3 to get 0.3 repeating. Okay, so I'm using prior knowledge here. We know that 1/9 is point repeating. So 2/9 must be double that, or 2 times that. 3/9 is 3 times that, or triple that. Okay, now 4/9, same thing. So get the idea. So 4 times 1/9, so that's 4 times 0.1 repeating. So that's got to be 0.4 repeating. And again, you can verify all of this with a calculator. So verify, all right, with a calculator. Any calculator will do. Okay? Okay. 5/9, same thing. Oops, not 6, but 9ths. So 5/9, that's the same as 5 times 1/9, commonly known as 0.1 repeating. So this is 0.5 repeating. So if you know the basic fraction, if you know this, and I'm going to say we know, if you know this right here, 1/9 can help you figure out all the other fraction with the same denominator, all the other fractions. All right, 6/9 reduced to 2/3 will give you information on 2/3. But 6/9 is the same thing as 6 times 1/9, right? Because 6 times 1/9 is 6/9. That would give us 6 times 0.1 repeating, which is 0.6 repeating. So you get the idea. And this pattern continues. And so let's continue. So 7/9 is the same as 7 times 1/9, which is 7 times 0.1 repeating, or 0.7 repeating. And then the last one, 8/9, same thing. You have 8 times 1/9, which is 8 times 0.1 repeating, which gives you 0.8 repeating. And all of this can be verified with a calculator. Okay, so let's go ahead and generate that too, by the way. So let me just verify one, just so you guys believe me here. So 8/9, so 8 divided by 9. This is what I mean by verify. 0.8 repeating. It rounds the last digit up because the calculator can only show you 9 or 10 digits. All right, but that's 0.8 repeating. So verify with the calculator here, and you're good to go. So it helps to know some basic fractions. Now let's take that and let's connect it to what's called infinite geometric series. All right, so question number 2. Q2. Let's go up to the top. Down below. Okay, so as we discovered in the activity, 1/9 is a rational number with the equivalent decimal repeating as 0.1 repeating. I don't know why it keeps doing that. So how can you use the sum of an infinite geometric series to verify the equivalences? Okay, so let's do that. So if you don't remember this from Algebra 2, don't worry about it. Okay, so I'm going to start off with what we know. So we know, it's powerful when you say that. So we know that 1/9 is equal to 0.1 repeating. So I'm going to write out the decimal, okay? So 0.1111111. So when you do this, and it repeats infinitely, when you do this here, it's helpful to write out the decimal. So show the digits. First of all, it helps, especially in the first time here. Okay, now watch this. So when you write this out, so I'm going to rewrite this here in an infinite geometric series. Now, series is a sum. Sequence is just a bunch of terms, but a series, a geometric series, is a sum of the terms. So what I'm going to do is I'm going to rewrite this using the sum of terms. So that first term here, 0.1, that's our first decimal here. So I'm going to write it 0.1, so 0.1 here, plus, and again, I'm going to write it as a sum, plus the second one here. Now the second digit is in the second place, right? So I need a 0 as a placeholder. So I've got 0.01. So again, that's in the second place, in the second decimal place. So that stands for 100th. So I wrote it as 0.01 or 100th. And then the third one here, this third digit here is in the thousands position. So it needs 2 zeros as placeholders. So 0.001. Then the fourth one here, 1, 2, 3, 4, this fourth digit here is in the 10,000s position, so I need 3 zeros as placeholders, 0.0001. And I can keep on doing this and keep on writing this infinite decimal, okay, as a sum of decimals, okay? It's a sum of decimals, so I'm going to go ... This is continuous. So this is how I decompose the decimal into its parts. So that's basically what I'm doing. In fact, let me write that down. So I decompose, okay, the decimal into its parts using place value, okay, into its parts using place value. So if you know the place value, this should make sense. The first position is tenths. The second position in green is hundredths. That's 1/100ths. Third position is thousandths, so 1/1000th, so 0.001. Fourth position is 10,000ths, so 0.0001. Okay, so I'm using place value here. Now I want to convert to fraction. Okay, so from here to here, convert to fraction. Okay, so let's do that. So this is equivalent to 1/10 plus 1/100th plus 1/1000ths, 1/1000ths. So 1 plus 1/10,000ths plus ... This continues. So I'm decomposing the decimal into its parts using place value and using what I know about place value. Okay, Now this is an infinite geometric series right here. Again, series is the sum of fractions or terms. This is called an infinite geometric series. So let me write that down. So this is infinite geometric. I'll explain why in a minute. Okay, series. All right, it's a sum, an infinite sum. Okay, so why is it geometric versus arithmetic? Okay, and the reason why is that we have to multiply the first term, this is called the first term right here, by something to get to the second term. So the question is, what do you multiply this by 1/10 by to get to 1/100th? What do you multiply to get to 1/1000th? What do you multiply it by? And what do you multiply it by to get 1/10,000th? Now, if it was arithmetic, you would add something to the first term to get to the second term. But that's not possible here. It has to be consistent all the way through the sequence, and addition or subtraction, it's not going to cut it. It's not going to work. So what do you multiply 1/10 by to get to 1/100th? So let's go off to the left here. So the key, one of the keys here is like 1/10 right here times what, I'm going to put a question mark, is equal to 1/100th. What fraction would that be? 1/10 times what gives you 1/100th? And the only fraction that's possible, okay, the only possibility has to be 1/10, because 1/10 times 1/10 is 1/100th. So this right here is called a common ratio. Okay, so I'm going to put it in red. So 1/10 times 1/10 gives you 1/100th. Times 1/10 gives you 1/1000th. Times 1/10 gives you 1/10,000th. And then again, if you keep on doing this, you're going to get all the terms in the infinite geometric series. Okay, so that's called a common ratio. I'm going to put this in red because it's important. Okay, so R is equal to 1/10. Common ratio is R. Okay. All right, so what else do we know? We also know the first term, so let's denote that here too. So first term, that should be obvious right here. First term, it has a name, it's called A1. We use A for the terms, A sub I, and A sub 1 here is equal to 1/10. So we use certain variable notations for this, guys. A sub 1 is the first term, R is the common ratio, whatever number you multiply to get to the next term in the sequence, or excuse me, in the series. Okay, and now all you need to know is from back in Algebra 2, all right, how to calculate an infinite sum. So the summation formula here, so it goes like this. So this deals with infinite sums now, so let me put that down. So infinite sums only, not finite, but infinite sums. Okay, we use capital S for sum. All right, and that's going to be equal to A sub 1 divided by 1 minus R. This is how to calculate an infinite sum. And believe it or not, even though there's an infinite number of terms in the series, it only depends on your first term divided by the common ratio. So remember, A sub 1 is first term. R is common ratio. That's it. So let's calculate it here. Let's figure this out. So here we go. This is going to be equal to, and by the way, you want to memorize this formula here because we're going to be using it throughout the entire lesson. So it's always first term A sub 1, which is 1/10, divided by 1 minus R. R is 1/10. And believe it or not, this will give us, when we simplify it, it better give us 1/9. Okay, so up top is 1/10. 1 minus 1/10 is obviously 9/10. You know, you take 1/10 away from one whole, then 9/10 remain. Okay, and when you want to multiply by the reciprocal here, so let's do that. So take 1/10 up top times the reciprocal of the denominator, so that's 10/9. So right here we multiply by the reciprocal. Multiply by the reciprocal, and by the way, that's I've talked about this in the prior lessons in the first section here, so this is important. Whenever you divide fractions, you multiply by the reciprocal. So you see the times symbol right here. So you take the numerator times the reciprocal of the denominator. Okay, so you simplify a little bit. Usually 10 divided by 10 is 1, and that gives you a result of 1/9. Okay, so the sum is 1/9. And guess what? We better get 1/9 because that's what it came from, right? All these terms came from 1/9. And that's how you calculate or change or convert to a fraction when you're given an infinite decimal. Without using a calculator, by the way. So no calc on this. Okay, no calculator. So let's make a little note. No calculator here. You can verify it, but don't use it on a regular basis because you're supposed to learn the techniques. So no calculator, only use it to verify. So let's do this. Let's reverse the process here. I'm going to give you a decimal and you're going to convert the fraction. So we're going to go backwards. Because on our next activity here, on activity 2D2, I give you the decimal and you come up with its fraction. Okay? And you're going to do that with no calculator. We can use it to verify only. No calculator. Okay, number 1. Okay, verify only. Okay, so the question is, how do you take these decimals and use the infinite geometric series approach to change it to a fraction? Okay, convert an infinite decimal to a fraction. That's what this activity is about. So convert, okay, an infinite decimal to a fraction. That's the goal. Okay, let me write down goal. So this is the goal. Convert, underline that word. Okay, so before we get to that, I think it might be appropriate if we do a few more examples, because sometimes 2 digits repeat, like in the next set of examples here, 0.45 repeating, 0.045 repeating, and then sometimes 3 digits repeat, and sometimes 4 digits repeat, and so on. So how do you do that? So you kind of need a little bit more than one example here. This right here is not enough. All right, so let's get into some more examples before I have you launch the activity in our next lesson here. So let me just, whoops, didn't mean to do that here. I just need to insert some space. One thing about this right here, it's kind of cool in that you have an infinite page, which is kind of cool. Okay, so let me pose the next question here. So let's work with a decimal here. Let's convert to a fraction. Okay. So the goal is to convert, all right, to a fraction, a rational number. Okay, no calculator involved. So no calculator. Okay, there's our goal. So let me pose the question here. Let's say we have, so you're given 0.45 repeating. So you're given that. That's the problem. And we want to convert to a fraction. No calculator allowed. All right. And so here we go. So what we're going to do is we're going to rewrite the decimal, and we're going to decompose it into its parts. So this is equal to, okay, 0.45454545, write it out, 4545, and continuing, continues infinitely. Okay, so just keep that in mind. All right, so the reason why I always do that for kids, especially in the beginning here, is because with any mathematical example, it's helped to see it because, this is abstract. Okay, so let's decompose it into its parts. So here we go. So let's do this. Let's underline the first 2 digits. So this is equivalent to 0.45 plus, I'm going to switch colors each time, Then the next two digits right here, the next pair of digits that repeats, because 4, 5 repeats, not just the 4, not just the 5, but the 4 and the 5 together. Notice that they're the third and fourth digits. And so really, if you look at place value here, we need two digits, two placeholders for the second group. Okay, so that's 0.045. And then the third group here, so let's do it at least 3 times here. We need 1, 2, 3, 4 digits for placeholders. So plus 0.00045. And then this keeps on repeating. So this fourth one here, 1, 2, 3, 4. We need 2, 4, 6 zeros as placeholders. So 1, 2, 3, 4, 5, 6, and then 4, 5, and then plus dot, dot, dot. So you decompose it first into its parts. Okay, step 2. Okay, so this is step 1. Okay, step 2 would be to write them as fractions. So write, all right, as fractiones. So let's do that. Here we go. So the first fraction, 45 hundredths, plus second fraction, 45 10,000ths. Remember, place value, tenths, hundredths, thousandths, 10,000ths. The most common mistake here is that people do not understand place value and they write down the incorrect denominator. So second one, you can also just count the digits too. So if you see 4 digits to the right of the decimal, then you're going to need 4 zeros. That's another way you can think of it. Like this one has 6 digits. So this is 45, then 1, 2, 3, 4, 5, 6. And so that's 45 millionths. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So this is 45 millionths. Okay, and then the next one, if you want to write it out, it would have 6 plus 2 is 8, so you need 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8, and then put the commas in so you can read it. So tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millions, 100 millions. So 45 100 millionths plus dot, dot, dot. So yeah, I'm going over a lot of place value, a lot of things that relate back to when you learned this back in grade school, believe it or not. Okay, so now we need to figure out the first term and all that. So here we go. Here's the mathematics. So this right here, this is your first term. So a sub 1 is equal to 45 hundredths. That you call that the first term. That should be obvious. Okay, now what's not obvious is the common ratio. So what do you multiply the first term by to get to the second term? I mean, the numerator is the same, but what's the denominator? I mean, how do you convert from 100 to 10,000? What do you multiply that by? And then what do you multiply to get to the next denominator and the next one? What do you keep on multiplying by? This is called a common ratio. So we went from 100 to get to 100 to 10,000. Okay, you got to multiply by 100, but it's in the form of a fraction, 1/100th. That is called the common ratio. The most common mistake there I see is people put 100 down, okay, and it's not 100, it's 1/100th. Okay, so we got to keep that in mind. So R is equal to, the common ratio is 1/100th. It's called the common ratio. Okay, and now you go for it. Now you calculate the infinite sum. So remember, S stands for sum, and it's always a sub 1 divided by 1 minus r. So you have to memorize this. And you will if you do your homework correctly. Okay? So S is equal to the first term, which is 45 hundredths. Yeah, that's right. Divided by 1 minus the common ratio of 1/100th. All right, and don't panic, don't freak out here. I know I'm dealing with fractions. So the numerator is just 45 hundredths. 1 minus 100th. If you take out one part out of 100, then 99 out of 100 remain. Okay, simple subtraction. You know, 100ths, one whole is 100 hundredths, minus 1/100th gives you 99 hundredths. Okay. Now we multiply by the reciprocal. So you take the top fraction times the reciprocal of the bottom one. So times 199ths. That's the multiply by the reciprocal part. Multiply by the reciprocal. Let me highlight that. That's important. Okay, and what do you get? Well, you simplify, right? 100 divided by 100 is usually 1, and so we get 45/99. And now you check it. And by the way, I know I might be going fast for most people, but guess what? You have to know that this is a video, and you guys ever hear the pause, play, and rewind buttons here, okay? So keep that in mind. You could pause and play anytime you want, rewind it, and listen to it as many times as you like. And notice that I just verified it is correct. Okay? Now, slight variations. I'm going to do one more here because in the activity, this one here, notice the decimals, 0.05 repeating, 0.045 repeating, 0.0045 repeating. And then, how does one help you out with the other? So let me just change this up a little bit before I just, give you guys the activity here. So let me just grab a little bit more space. Okay, I want to do one more here. So instead of 0.45 repeating, okay, I'm going to change it up a little bit here. Okay, so now, given 0.045 repeating, and put the bar over the 4 and the 5, not the 0. So that's the given. Okay, now let's write this out. So 0.045. Remember, only the 4 and 5 repeat here. So 4, 5, 4, 5. So it kind of looks like the same one as last time, right? It looks like that, right? Come on, am I right? It kind of looks like it. All right, but watch this. That 0 right there in the tens position changes things up a little bit. So we're going to do the same strategy here, but we're going to be careful because it's slightly different. So I'm going to decompose it. Okay, so here we go. Underline the first group here. So this is equal to 0.045 plus. And again, if I go too fast, pause the video. Second group, 0.00045. Remember, there's 3 digits prior to the second group. So we're in the 4th and 5th positions here. So you got to have your zeros as placeholders. And then third group, 1, 2, 3, so plus point, and we need, let me see, there's 5 digits before that, so 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, and then 4, 5, okay, and this goes on and on. Okay, now, you do what we did before, you write them as fractions. So here we go. So the first fraction here is not 4500ths like up top. New. It's 45 thousandths. So be careful there. And there's the difference. Compare the previous problem with this one. You can see it's different. Okay, the next one is, it's in the 5th. The 5 is in the 5th decimal spot. So we're in 100 thousandths. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this is 45 hundred thousandths. Okay, and the next one here, it's 45, and then we need 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. So we're talking about 45 millionths. Oh, you know what? I made a mistake somewhere. What happened? Oh, I didn't write it correctly here. I got to back up. The third group is 1, 2, 3, 4, 5. 5 zeros. I only put 4. So there's 1, 2, 3, 4, 5. Oh, I think I had it right. So I need 1, 2, 3, 4, 5, 6, 7 zeros. Okay, so here we go. So 45, and then 1, 2, 3, 4, 5, 6, 7. So you're talking about 10 millionths here. 45 10 millionths. Above it was 45 1 millionths. This is 45 10 millionths. So it's slightly different, right? Okay. Now let's figure this out. Here we go. So capital S stands for sum. So it's always the first term. Oh, I'm backing up. I'm going too fast. Okay, so our first term here a sub 1 is equal to 45 thousandths. The common ratio, what do you multiply by to get to the next terms? Well, 1,000 times 100 gives you 100,000. So this has got to be 1/100th here. Okay, so the common ratio is the same as the previous problem, but the first term is different. Aha. Okay, so pay notice to that. So r is equal to 1/100th. So these problems are similar in that the common ratio is the same, but the first term is different. In the previous problem, it was 45 100ths. This problem is 45 1,000ths. So you got to be careful here. Okay, so here we go. Sum is always the first term divided by 1 minus r. So we're going to take 45 thousandths divided by 1/100th, excuse me, 1 minus 1/100th. Just follow the flow. And we've got 45 thousandths divided by 99 hundredths. And at this point, you want to multiply by the reciprocal. So you take the top fraction, which is 45 1,000ths, times the reciprocal of the denominator, which is 199ths, just like we did up top. I'm talking about this step here, okay? Same step. Okay, and then what do you get? Well, simplify. Divide both of these by 100. 100 divided by 100 is 1. 1,000 divided by 100 is 10. So you divide both by 100 and simplify. People call that cross cancel and simplify when you were young. Oops. So cross cancel and simplify. It's what you guys did back in 4th grade. I keep doing a lot of elementary math in this class because all of this stuff was learned back in the day. And then 45 times 1 is typically 45, and then 10 times 99 is 990. And then of course you better check that. So 450, or excuse me, I didn't say that right. So 45, okay, that's much better, divided by 990. So there you go, and you can see that it is the same decimal, 0.045 repeating. So it is possible, all right, to learn from it, and so learn from the past. So just so you know, if I gave you this right here, 0.0045 repeating, you know, that's the same thing as this one here, but it is you're taking 1/10 of it. So it's the same as 0.045 repeating divided by 10, because you know it has one more zero as placeholder. Or you can write it as 1/10 times 0.05 repeating. You can write it that way. And then you could take 1/10 of the previous answer here, which is right up here, 45 over 190 here, and then you get just 45 over 9,990. So you could take prior results if you knew them and then extend it without doing all the process. So it all depends on what you know and what you know in terms of the basics. All right, that was a big lesson right there, but guess what? It's going to get you guys ready for activity 2D2, excuse me. All right, and once again, in any video here, if you need some more help or if you're not sure about it, you can always go back and revisit it and go ahead and listen to the previous work. Okay, so this activity, this little video here is getting you prepped and ready for activity 2D2. Which is coming up in our next lesson here. Oh, here it is right here. Getting a little crazy on the computer here. Where you're going to convert these other decimals to fractions too, using what's called an infinite geometric series approach. Okay, that's Mr. Ainsworth, or I'm Mr. Ainsworth here. I'll see you in my next lesson. All right, take care. Bye-bye.